Hi, my name is Anshu and welcome to my channel Bottleneck. This is Data Structures and Algorithm series. Alright, in our previous video we discussed about what is Fibonacci series and we implemented recursive top-down and bottom-up approach to find a Fibonacci number for a given index. Now in this video we are further going to extend our dynamic programming examples and we are going to implement another problem statement which is known as flower box problem. Alright, so what is a flower box problem? So we have few places to plant flowers. For example, say we have 3, 10, 3, 1, 2. Now, each place you plant flower will have some amount of nutrients, and once you plant the flower, the height of the flower will be proportional to that nutrient. So if you plant the flower at the first location, the height of the flower will be 3. And so if you plant the flower at the second location, the height of the flower will be 3 or 10. So in total, we have the height 10 plus 3, which is 13. Now, the objective or the goal is to find the maximum possible height that we can have for the given flowers when planted in these locations. But we have some set of rules or the constants. So what are the rules? You can plant as many flowers as you want as long as they are not right next to each other. All right. So we can, if we plant at 3, we cannot plant at 10 and so on. Let's implement this. So flower box, and it is going to take input as sequence of int. All right, and it is going to return an int. Very well. And now sequence dot fold left. Now here we are going to provide initial value as 0. We will start with initial as the optimal height, which is nothing. Now as we iterate through, we will be evaluating on the heights and accordingly we will be selecting the optimal value. How are we going to do that? Let's implement a pattern match case, and we are going to have two values, a comma b, same as what we had in our bottom up approach. All right, and there will be an index. Now what we need is, first value is going to be b, second value is going to be max of a plus v comma b, and we are interested in the second or the last value. So this is how we are going to implement it. All right, let's run it. So let's give the flower box a sequence of value 3 comma 10 comma 3 comma 1 comma 2. All right, and let's see now, let's, before we print this, let's trace the data. So what we can expect. All right, so first input that we have is a comma b, that we are providing as 0 0. Now we also have v, that will be the value that we will be iterating through over the sequence, and what we are calculating is b comma max of a plus v comma b, and then henceforth b will be updated. All right, so the first value that we have is 0 comma 0, and the value of v is 3. Now then it is going to return, so v will be 3. All right, so now we are going to select, so we have b as 0 and max of 0 plus 3 comma 0, which will give us again 3. Now the next iteration would be, as we see, 0 comma 3. All right, and now the value of v would be 10. Now here we are going to have 3 comma max of, again, so you can guess what it would be. So it is going to be a, so that is going to be 0 plus 10, that is the value of v, and the value of b, that is 3. All right, so it is going to return 10. Till now we have the optimal height as 10. Now we will iterate further, so it will go. Now the value of a is going to be 3 because b is going to return. So every time whatever the value is b is will become a, and the new value here we have 10. All right, now the v is again 3. Okay, so now how it is going to look like? So we have the value. So the first value or the b is 10, and we are going to find the max of, now it is going to be a, that is 3 plus 3 comma 10. All right, again it is going to return 10. Okay, so we will have next iteration. So now the values will be 10 comma 10. All right, now v is going to be 1. Now again we will have same iterations. So it is going to be 10 comma max of 10 plus 1 comma 10. So this is going to return 11. All right, so we are so far so good. Now we are almost at the end. So the value that we are going to have here is 10, and this will be 11, and the last, but the value for the last one is 2. All right, so here it is going to be 10 comma max of, again, so it is going to be 10 or say 11 or 10, sorry, the a is 10 plus 2, and here we are going to have 11. All right, so this is going to return 12. So the expected output or the result would be 12. That's what we are going to expect. So at the end it is going to be 11 comma 12. Now you can also see this as backtracking because we are tracking backwards and we are tracing out the value of 2. All right, let's run this and see whether we have achieved our result or not. Before that, let's comment these out so that we don't spend much time on running all of these. All right, okay, so let's run and see, do we achieve as expected or is there any bug in the logic? So we are expecting that the final result would be 12. So if we see through, so 10 plus 2, that would be the maximum value that is possible. All right, so we are getting 12. Now you can test this with different sequence. This is very well going to work, and functional programming makes it very easy, one liner to implement this. All right, so if you enjoy this video, please like and subscribe, and we will be solving other most popular problems like knapsack and others in due course of time using the dynamic programming, and we will be doing a data walk over all of them to understand in detail. All right, so thank you and see you in the next video.